Alrighty, this is Unit 1, Day 2 assignment, Operations on Functions. Again, I'll work the odd problem with you, or what a selected few problems, whichever I see fit. For problems 1 through 4, they ask us to find the four basic operations using f of x and g of x. So for the first one, we're going to take f plus g of x. That means take f of x plus g of x. F of x is x plus 5. G of x is x minus 4. And then we combine our like terms. I have x plus x, which gives me 2x. And then I have positive 5 plus a negative 4, which is a plus 1. Now we'll do f minus g of x. Again, it tells us to take f of x minus g of x. So that's x plus 5 minus x minus 4. Again, when you have subtraction, I highly strongly recommend that you add a line, change all signs, and then simplify or combine your like terms. So x minus x is 0, and then you have 5 plus 4, which is 9. Now we're going to do f times g of x, which means f of x times g of x, literally. So that's x plus 5 times x minus 4. And I would use parentheses when I'm multiplying. And now you would use the FOIL method to multiply. So x times x squared, x times negative 4, negative 4x. 5 times x is 5x. And 5 times negative 4 is a negative 20. Or you can use the box and you would get the same result. So you would get x squared plus x minus 20 as a result. And now we're going to do f divided by g of x, which means we're going to take f of x and put it on top of g of x. So that's x plus 5 over x minus 4. When you're doing the division problem, make sure you also include values of x that make the denominator 0. So the easiest one way to find that out is take the denominator, x minus 4, equal it, put it not equal to 0, and solve for x. So when I solve for x, I would have to add 4 to each side, which means that x is not equal 4. So both of these are necessary for that part. And again, this was all problem number 1. On problem number 3, again, we carry out the same operation. So f plus g of x is f of x plus g of x. So x squared plus 4 minus x. And then combine your like terms, if any, and there are none in this case, but we can rearrange it so that it's in the proper order. So that's x squared minus x plus 4. For f minus g of x, we take f of x minus g of x again, and we would take x squared minus 4 minus x. And again, it's a subtraction situation. So I always say add a line, change all signs, and then combine like terms. Again, there are none, but reorder. So it's x squared plus x minus 4. Now we'll do f times g of x, f of x times a g of x. So x squared times 4 minus x. So now we distribute x squared. So x squared times 4, 4x squared. X squared times x, x cubed. And lastly, rearrange the order. So it's negative x cubed plus 4x squared. Largest powers come first. That's why I say when I mean rearrange the order. And lastly, we have to divide. So f divided by g of x is f of x divided by g of x. So x squared divided by 4 minus x. Again, take your denominator, 4 minus x, set it not equal to 0. Solve for x. So the first thing I would do is subtract 4, which would leave with a negative x not equal to negative 4. And then divide both sides by negative 1. So you would have x cannot equal 4. And again, that is for number 3. All right, for problems 5 through 8, if it's an odd problem, we're going to do the fog composite, F composition G. If it's an even problem, we're going to do G composition F and state the domain and range of the composite. So for number 6, when it comes to, it's an even problem, so we're going to golf. So what you're going to do in this circumstance is write out your candy shell, which is G, the first number. Open up a set of parentheses. And inside those parentheses, we're going to take all of the ranges or the y values of f. All of the ranges of the y values of f. Why we're using f? Because that's your gum. So we're going to replace the y values of f into those parentheses. So when I look at f, I have a negative 3, a 2, and a 2. So essentially it's just negative 3 and 2. We don't need this extra one here. Now, I'm going to find the value of g when x is negative 3, and I'm going to find the value of g when x is 2. So when x is negative 3, g is equal to 1. When x is 2, g is equal to 0. So the domain of the composite, so the domain of Goff is negative 3, 2. The range of the composite is 1, 0. I'm sorry, the domain of the composite was 0, 1, and 2. It was the x values of f. All right, for number 7, since it's an odd problem, we're going to fog. So F composition G. So that means my candy or outer shell is F. So go ahead and write him down several times over with the blank parentheses beside. And again, we're going to fill those blank parentheses with the y values of your gum. In this case, our gum is G. So G has a negative 4, a negative 1, and a negative 1. Again, negative 1 repeats, so you should only need to write it once. So I don't need to write that one. Now we're going to look at f and find the value of f when x is negative 4. So when x is negative 4, y is 3. When f is negative 1, y is 1. So the domain of our composite is equal to 1, 2, 3. The range of our composite is equal to 3, or 1, 3. I know, we want to put them in order, ideally. And I didn't do that on number 6, but try to make sure you list them in order. If you don't list them in order, yes, it's okay, but try to make it a good habit. On the back side for 9 through 14, if it's odd, you're going to do G composite H. If it's even, you're going to do H composite G. So let's look at number 10. For number 10, it's an even, so we're going to do H composition G of X. So the candy of this blow pop, the candy shell, is the H function. So the H function reads 4x minus 1. Now I know the gum is going to replace x. So let's write 4 parentheses minus 1 because we need to fill that parentheses with our gum function in just a moment. So our gum function is g because it's closest to x, or it's the second one that appears. So I'm going to write 4, open my parentheses, and now I'm going to insert the gum into my blow pop candy shell. So that is a negative 3x, and then minus 1. So that's the composite component. That's all it takes is for you to set up your candy shell, open a blank parentheses wherever x is in the wherever x appears in the function, and then insert the gum function, whichever it is, inside of those parentheses. And now we have to carry out our algebra steps to simplify it. So we're going to distribute 4 into that parentheses. So 4 times negative 3x is a negative 12x. And then bring down the minus 1. I can't combine negative 12x with minus 1, so I'm now done. Let's look at number 11. Since it's an odd problem, we're going to do G composition H. So that means G represents the candy shell for this problem. G is x minus 6. So I see that there's one x in this problem, so let's open up a parentheses for x, bring down everything else. Now let's fill in the parentheses with the gum function h. So parentheses h is x plus 6, and then there's still a minus 6 trailing along. So that's the composite function right there. That's your whole blow pop. Now we combine like terms to simplify. So it would be x only because 6 minus 6 is 0. So now you should be able to finish the rest in that section. For 15 through 23, you're using these three functions at the top. F of x equals 3 of x, g of x equals x plus 4, and h of x equals x squared minus 1 to find the given value. So you work from the inner core outwards. So kind of like your order of operations, you start in your innermost parentheses first. So I see h of 0 in the middle in this core. So let's bring down g bracket. H of 0 means to substitute 0 in place of x. So let's do that. So we're going to open up our parentheses, squared minus 1. Bring down our g. In parentheses, we're going to fill it with 0. So 0 squared minus 1 is a negative 1. Bring down your g, your brackets. So now you're going to find g at negative 1. In other words, you're going to take the g function, and which is x plus 4, open up a parentheses for x, and then plus 4. So in that parentheses, we're going to put negative 1 now. So negative 1 plus 4 is positive 3. So that's all you're doing is you starting from the inner core, substituting the value for 0 or for x, and then working outwards. So whatever result comes with that is going to be needed for the next step or stage. Let's look at 19. Again, we're using G and H. So now we're going to find H at 3. So we have our parentheses squared minus 1 inside because that's the H function. And again, we're going to replace the parentheses with a -3 this time because that's what they want us to use. So -3 squared is a +9. +9 minus 1 is 8. So 8 is the result of that. Bring down your G and your brackets. So now we're going to find G at 8. So open up a parentheses for x because x comes first, and then +4. Now fill in your parentheses with 8. And now 8 plus 4 is 12. So again, start with the inner core and work your way out. Let's look at number 17, and this is our last problem. So 17 requires us to use G and F. So write G down, our brackets, and now we're going to use the F function, 3x. So it's 3 and then parentheses to replace x. And inside the parentheses, we're going to use -1 because we're not using x anymore. So 3 times -1 is -3. Bring down the G. And now we're going to take our G function, which is x plus 4, open up our parentheses, and put +4 afterwards. Insert the parentheses with -3 and carry out the computation. So -3 plus 4 is a +1. All right. I hope this tutorial is helpful for you to be able to finish the rest of your assignment on your own. Thank you for your attention.